Okay, guys, so today we're going to be doing a trigonometry review. We're just going to be covering basic trig, law of sines, and law of cosines. This is going to help you get ready for the SLO post test that we're going to take. Here's the first question. An A-frame house is 45 feet high, 32 feet wide. Find the measure of the angle that the roof makes with the floor. So I know that the height of this house is 45 feet high. This is also what an A-frame house looks like. It basically just looks like the letter A. So the height of the house from the top to the floor, they said was 45, and the width is 32. So on the floor, we'll have 32 feet. Now notice that we have a right triangle that is formed on either side. And so we can actually split this triangle in half into two right triangles that are smaller than the original one, because the question says find the measure of the angle that the roof makes with the floor. So if this is the roof and this is the floor, then we'd be looking for this angle. And so you see you can create that right triangle. So I'm actually just going to redraw it, and I'm only going to draw half of it so you can get a clearer picture. So the angle is still down here, the height is still 45. However, notice that since we're cutting the house in half to just get one side of the triangle, this will also have to be divided in half. So instead of 32, now the width is 16. For every right triangle, you're going to be using SOHCAHTOA. And remember, you always start by labeling your side. So across from the 90 degrees is your hypotenuse. Across from the angle is the opposite leg, and next to the angle is the adjacent leg. Now notice that we have information on the opposite and the adjacent. So between all of our options here, the only one that's going to work is tangent. So you have tangent, and tangent is always, well, any trig function is always attached to the angle. Since we don't know the angle, we'll just put theta is equal to opposite over adjacent. Now we have tangent theta, but we need theta by itself. So to get rid of the trig function, you multiply by the inverse of tangent on both sides. And then you're going to do theta. And then on your calculator, you're going to do inverse tangent. Let me open, I don't even have my calculator pulled up, sorry. So that was inverse tangent of 45 over 16. And make sure your calculator is in degrees. So you see we got 70.43 if I round up. But the question does say round to the nearest degree, so that would be the nearest whole number, so it does round to just 70 degrees. Okay, going to the next one. A 24-foot ladder makes a 58-degree angle with the ground. How many feet up a wall will it reach? So you see that we can create that right triangle from the top of the ladder to the ground, and then with the length of the actual ladder itself, and that does create the right triangle. So it says the ladder is 24, and the angle the ladder makes with the ground, so here is the ladder and here is the ground, so that angle will be 58 degrees, and it's asking us to find how many feet up the wall it can reach. So again, label your sides because you're going to be using SOHCAHTOA anytime it's a right triangle. So across from the 90 degrees is the hypotenuse, and across from the angle is the opposite leg. So we only have information on opposite and hypotenuse, so that forces us to use sine. So we have sine always attached to the angle. In this instance, we do have the angle, which is 58, x over 24. Anytime you have a fraction like this, you're always going to multiply by the denominator. It doesn't matter if x is here or if x is at the top. You will always, always, always multiply by the denominator to get rid of the fraction. Now we have 24 sine of 58, which is 20.35. But this says round to the nearest tenth, so that would be 20.4 as our final answer. Okay, here's the next one. A ship sonar finds the angle of depression to a wreck on the bottom of the ocean is 13.2 degrees. If a point on the ocean floor is 75 meters directly below the sonar, how many meters is it from that point on the ocean floor to the wreck? So with the angle of depression, remember that makes an upside down triangle. The first line you can draw is the horizontal line, which is if you're positioning yourself in the object, you're just looking straight forward. So since we're, on top with the sonar, if I look straight forward, I would see, the edge of the water. The line of sight is what connects both objects together. And then the vertical line is what you get when you just connect the two other lines we just drew. And then you see the 90-degree angle, which is formed. And it says the angle of depression is 13.2. It says that there is a point on the ocean floor. So it says a point on the ocean floor is 75 meters directly below. Directly below the sonar. So if this is the sonar, and let's say this is the ocean floor, there's a point directly below that is 75 meters below. Now, if this vertical distance is 75, then this vertical distance will also be 75. It is just shifted over to the right. And the question says, how many meters is it from that point on the ocean floor to the wreck? So again, this is the point on the ocean floor that's directly below the sonar, okay? From this point on the ocean floor to the wreck, that creates a horizontal line. That horizontal line is the same that we have on top of our triangle, therefore we're solving for that horizontal line. Again, we're going to use SOHCAHTOA, and we are going to label our sides. So across from the 90 degrees is the hypotenuse, across from theta is the opposite, and next to the angle is adjacent. We have opposite and adjacent, so we're forced to use tangent. We know the angle is 13.2. That's equal to 75 over x. Like I said in the previous problem, if you have a fraction, you will always multiply by the denominator. Here it is x, so I will multiply x on both sides so that they can cancel out. You're left with x tangent of 13.2 is equal to 75. Now to isolate x, you're going to have to divide out the tangent on both sides. And then you just put that into the calculator. We got 75 over tangent of 13.2, which is 319.76. Does it say how to round? No, I don't think so. That's fine. We'll just leave it like this in the hundreds place. Okay. Next problem. Find the angle of elevation of the sun if a building 125 feet tall casts a shadow 196 feet long. So with the angle of elevation, that creates a normal triangle where a leg is on the floor, and obviously the vertical leg is with the building. So it'll look like this. The height of the building is 125 feet. We're looking for the angle of elevation, and the shadow is 196 feet long. Now, there has been some misconception on where your shadow is. If you were to put your pencil on your desk right now and observe where the shadow is, you would see that the shadow is on your desk, creating a horizontal line. It is flat on the surface of your table. It is not in the middle of the air. So it would not be the hypotenuse. It would have to be on the floor, on the ground. So it's the horizontal line. On this instance, the shadow would be on the sidewalk or the road or whatever. Okay, so again, using SOHCAHTOA, we're going to label our sides. Across from 90 degrees is the hypotenuse, across from the angle is the opposite, and next to it is the adjacent. So since we have opposite and adjacent, we're going to do tangent. And then again, we're going to have to do the inverse to isolate the theta, which is the angle that we're looking for. The inverse and regular tangent cancel out. We're going to do inverse tangent of 125 over 196. Which is 32.53 if you round up. But this does say round to the nearest degree, so I will have to round it up to the nearest whole number, which would be 33 degrees. Okay, next problem, triangle CDE. Notice that my triangle is not labeled, so just label it however you want. I'll just label it like this. Just make sure that you have your angles where they're supposed to be. So angle C is 42 degrees, angle D is 30 degrees, and remember that the lowercase letters are across from the uppercase letters. So if this is capital E, then across from that will be little e. So over here we will have 4. Now, nowhere here does it say that this is a right triangle. If it doesn't say it's a right triangle, if it does not say angle of elevation or angle of depression, do not assume it is a right triangle. So if it's not a right triangle, you cannot use SOHCAHTOA, so you're forced to either use law of sines or law of cosines. Now, law of sines, you can only use it if you have a pair of an angle and a side of the same letter. So if you have angle A and side A, then you can use law of sines. If you have angle B and side B, you can use law of sines. So let's observe this triangle, see if we can find a pair. So I have angle D, but not the side. I have angle C, but not the side. I don't have angle E, but I do have the side. But notice that I already do have 2 other angles, so I could figure out what angle E is and then create the pair that I need to use law of sines. So to do that, to find angle E, you would subtract the other 2 angles from 180. So 180 minus 42 minus 30. Which is 108 degrees. Oops, wrong app. Okay, so now notice that I have everything that I need. I have my angle and my side. And since we're solving for little c will be across from angle C. I'm going to make sure to include the angle or the other letter that I'm solving for. Since I'm solving for C, I'm going to make sure I include C in my formula. So my formula will consist of sine E over E is equal to sine C over C, and then I'll just plug everything in. Angle E is 108, side E is 4, angle C is 42, and I'm solving for little c. Now at this step, you're going to cross multiply. So we have C sine of 108 is equal to 4 sine of 42. To get C by itself, I'll have to divide sine of 108. And then I'll put that straight into the calculator. So we have 4 sine of 42 over sine of 108, which is 2.8 approximately. Oops, wrong app again. 2.8. And it's to the nearest tenth, so that's perfect. Okay, moving on to the next question. In triangle PQR, not labeled, so I'm going to label it before I do anything else. Triangle PQR, side P is 12, side R is 7, angle Q is 39 degrees, and we're looking for side Q, which is again across from angle Q. So again, this is not a right triangle, so I can't use SOHCAHTOA. So I'm going to think about whether it's law of sines or law of cosines. For law of sines, I need a pair. I have angle Q, not the side. I have the side, but not the angle. I have the side, but not the angle. So there's no pair as of right now. I also can't figure out what these two are because I only have one angle. Since I can't create a pair, I'm going to have to use law of cosines. With law of cosines, whatever letter you are solving for is the letter you're going to start with. So since we're solving for Q, I'm going to start my formula with Q. And the formula is on the formula chart. You just have to change ABC to be PQR, but it's the same thing. And then just plug in your numbers. Now notice that on the left hand side I have Q squared. At the end though, I'm going to want Q by itself. So I'm going to save myself an extra step in my calculator calculation by just going ahead and taking the square root from the get-go, because these are going to cancel out and I'm going to get Q by itself. So in the calculator, I'll do the square root of 7 squared plus 12 squared minus 2 times 7 times 12 times cosine of 39, which is 7.901. But to the nearest tenth would just be 7.9. Okay, moving on to the next question. If cosine alpha is 5 over 13, what is the value of sine alpha? Now remember, if you use SOHCAHTOA, cosine is equal to adjacent over hypotenuse. So in essence, we now have two legs of the triangle. So this one is a right triangle. Now the alpha, or the angle, you can place it anywhere. You can place it on the top or the bottom. Your side will match up if you label it correctly. You just have to remember to place the angle first before you start putting the numbers. So now that I have the alpha here, my adjacent side will be 5. My hypotenuse is 13. On a right triangle, to find a missing leg, you use the Pythagorean theorem. Remember that the hypotenuse always has to be C, no matter what. So I'm going to say that my opposite leg is A, B is 5, and C is 13. I do have to subtract 5 squared on both sides. Some people like to simplify right here, like before you get started, like make it 169 minus 25. It doesn't really matter. And then you'll have to take the square root of everything to get A by itself. So I'll go to the calculator, square root of 13 squared minus, 5 squared, which is 12. So the opposite leg is 12. So I'll put that on my triangle. And then now we can figure out that sine of alpha is opposite, which is 12, over the hypotenuse, which we know is 13. And they did not say find alpha, they just said find sine of alpha, so you will leave your answer as a fraction, as a ratio of the triangle. Now the next question is the exact same triangle. It's the same thing, as just asking you for a different ratio. So I'm still going to have the right triangle here, alpha there, adjacent is 5, hypotenuse is 13, and the opposite leg we calculated last time was 12. So tangent alpha, remember that tangent is opposite over adjacent, so the opposite leg is 12, the adjacent leg is 5. And that's it for this one, 12 over 5. On to the next problem. What is 45 degrees converted to radians? So remember, the conversion is 180 over pi. Now you should always have your degrees lined up. So if you do degrees radians, your other fraction should also be degrees radians. Or if you want to do radians first and degrees at the bottom, just make sure the other one starts with radians and has degrees at the bottom. They need to line up horizontally, degrees, radians, and vice versa. You can't mix match. You can't put degrees at the top and then at the bottom on the next one. They got to be the same. So since I have 180 degrees at the top, I'm going to put 45 degrees on the top for the second fraction. And I don't know how many radians it is, so I'll put an X so I can solve for it. You're going to cross multiply. We have 180x is equal to 45 pi. To isolate x, I'll have to divide out 180. Now, to simplify this, where you guys mainly went wrong on the test and the quiz was including that pi in the calculator. All you're going to put in the calculator is the fraction in front of the pi. You're going to simplify that fraction because at the end, you're going to leave that pi in the numerator. So notice that radians in the unit circle always have a pi. We got pi over 3, pi over 4, pi over 6, pi over 2, 2 pi over 3, 3 pi over 2, 4 pi over, I don't even know, so many other, but they all have a pi. So if I'm asking you for radians, don't get rid of the pi. It has to be included in your answer. So I'm going to simplify 45 over 180. And I get, and making sure it's a fraction, I don't want decimals, it's 1 over 4. So in the numerator we have 1, denominator we have 4, and that does simplify. 1 times pi is just pi. 1 times anything is what you're multiplying by, so final answer is pi over 4. Okay, moving on to the next one. The line of sight from a small boat to the light at the top of a 40-foot lighthouse built on a cliff 30 feet above the water makes a 15-degree angle with the water. To the nearest foot, how far is the boat from the cliff? Okay, so it tells me that the lighthouse is 40 feet and that it's sitting on a cliff that's 30 feet above the water. So the lighthouse is 40, the height of the cliff is 30. Okay, so in total, the entire height from the ocean to the tip of the lighthouse will be 40 plus 30, which is 70. So if I create my actual triangle from the top of the lighthouse to the bottom of the ship and making my 90-degree angle, notice that the height is actually 70 because I have to include the cliff and the lighthouse. It says we have a 15-degree angle with the water, so that's going to be down by the ship. And then we were trying to figure out how far is the boat from the cliff. So if this is the cliff and this is the boat, we're looking for the horizontal distance. Now this is a right triangle, so I'm going to be using SOHCAHTOA. And I'm going to label my sides. So next to my angle is my adjacent, and across from the angle is the opposite. I have no information on the hypotenuse, so I won't be using that one. Since I have opposite and adjacent, I'm going to be using tangent. So we have tangent of 15 is equal to 70 over x. Again, always multiply by the denominator. So I have x tangent of 15 equals 70, and I will have to divide out tangent so I can isolate x. And then I'll put that into the calculator. 70 divided by tangent of 15, which is 261.24. But this question does say to the nearest foot. So that is to the nearest whole number, which would just be 261. Okay, moving on to the next question. An airplane is flying at an altitude of 10,000 feet. The pilot wants to make a smooth final descent to the runway at an angle of depression of 9.5. How far from the runway should the pilot begin the descent? So remember, angle of depression, you start with your horizontal line, which is where you can envision yourself as the pilot. So that's looking straight forward into the sky. If you look down at the runway, that creates your line of sight, and your vertical line is just connecting those two lines together. This is not cooperating with me. Okay, there it goes. Sorry, you guys, I'm a perfectionist. You know this already. Okay, that creates a 90-degree angle. The angle of depression is 9.5. Since the plane, the altitude is 10,000, this vertical distance will also be 10,000. And we're trying to figure out how far from the runway should the pilot descend. So from the runway would be how far away would be the horizontal distance. So we're going to put an X there. So I have my opposite and my adjacent, so we will be using tangent again. We've been using tangent a lot. So we got 10,000 over x multiplied by x, always multiplied by the denominator, like I've said a few times already. And then divide out so you can isolate the variable. Those will cancel out. So we got to go put 10,000 over tangent of 9.5, which is 59757.64. So 59757.64. And I don't think it said how to round, so that's fine. We'll just leave it in the hundreds place. Okay, moving on to the next one. Jill is standing 75 feet away from a tree. She can see the base of the tree from an angle of depression of 20 degrees. To see the top of the tree, she must look up to an angle of elevation of 50 degrees. How tall is the tree? I included two separate pictures because we won't be creating two separate triangles, one that's angle of depression and one that's angle of elevation. And then we'll have to use them both together to find out the total height of the tree. So if I zoom in to this first picture, So this is going to be the angle of depression. Remember, you start with your line of sight, which is from her eyeball. She's going to look straight across, straight forward into the tree. If she looks down to the floor, and then we connect those two lines, we create our 90-degree angle. And so it said that the angle of depression was 20 degrees, and they said that she was 75 meters away from the tree. Now, since I'm wanting to figure out the height of the tree, I am going to want to know the vertical distance so I can start to piece together the height of the tree. So we'll come back to that. I'm going to come over here to this one to create the angle of elevation. So again, the horizontal line is still going to be from her eyeball, looking straight forward, but now instead of looking down, I'm going to look up to the top of the tree, and then that'll create my triangle. So that creates the 90-degree angle. This angle of elevation was 50 degrees, and she's still the same distance away. She's still 75, and we're still trying to figure out the height. So notice that one triangle will give me the trunk, and the other one will give me all the branches. So if I add them together, I will actually get the entire height of the tree, which is what we want. So I'm going to solve for x now. So across from 20 is opposite, next to it is the adjacent. So that'll be tangent of 20 is equal to x over 75, always multiplied by the denominator. So I'll go ahead and put that in the calculator in a second. I'm also going to do this one. So across from the angle, opposite, next to it, adjacent, that's tangent again, is equal to x over 75 multiplied by the denominator. So I have basically the same calculation but with different angles. So we got 75 tangent of 20 and 75 tangent of 50. So the trunk height is 27.29. And the branches part is 89.38. Now I'm going to have to add them together because that's going to give me the entire height of the tree. So I'm going to I was trying to copy and paste it, but I don't think it's going to let me. Okay, well, I give up. 27.29 plus 89.38 equals 116.67 for the total height of the tree. Okay, moving on to the next question. The base of an isosceles triangle has a length of 24 and a vertex angle measures 88 degrees. What is the length of each leg? So with the isosceles triangle, I made a little, well, I just got it from the internet. I didn't make it, but I put it here for you guys to see. For an isosceles triangle, the two legs are the same exact length. The base is different though. So we have two equal sides. So that means that the base angles are the same, but the vertex angle is different. So since it said the vertex angle is 88, that's going to be up here at the top. And the base is 24. Now we're trying to figure out the length of each leg. So we're looking for these two, which will be equal to each other because they are the same. So we have 180. We can figure out the other two. We can figure out the two angles that are missing because since they're the same, we can just subtract 88 and then divide them by 2. So we got 180 minus 88. What does that give me? 180 minus 88 is 92. But if I divide that in half, I get 46. Because since they're the same measurement, these will both be 46 degrees. Okay. And then what did I say? Okay, that's fine. So you're going to have to divide that in half. So now, notice that we can actually use law of sines because I have an angle and a side pair. So I have angle 88 and side 24. And you can use either angle because they're the same and the leg is the same. So we can have sine of 88 under 24 is equal to sine of 46 over x. Cross multiply. Remember that the angles always go with the sign. There's been some confusion over that. Okay, and now you just gotta isolate x. We can put that in the calculator. 24 sine of 46 divided by sine of 88 is 17.27. And it says round to the nearest 100th of a foot, so that is 2 places after the decimal. So we are done with this one. Okay, there it goes. All right, next one. A post is supported by 2 wires, one on each side going in opposite directions, creating an angle of 60 degrees between the wires. So between the wires, here's wire 1, here's wire 2. That angle between the wires is the one at the top. So this one will be 60 degrees. The ends of the wires are 20 meters apart. Here's the end, here's the other end. So right across from that, they're 20 meters apart. And one wire is 55 degrees with the ground. It doesn't say which one, so it really doesn't matter where you place it. And then it says find the lengths of the wire. So we're looking for wire 1 and wire 2. So notice that I have a pair, I have an angle and a side. I also have an angle and a variable that I'm solving for, so I can use law of sines here. So I have sine of 60 over 20 is equal to sine of 55. And we'll do W1 for wire 1, and we'll cross multiply. So wire 1 times sine of 60 is 20 times sine of 55. Divide. So wire 1 is 20 sine of 55 over sine of 60, which is 18.9. So that's the first wire. For the second wire, we're missing an angle, but notice that we can find that missing angle by just subtracting the existing ones from 180. So 180 minus 60 minus 55, which is 65 degrees. So now for our second operation, we'll do wire 2 but with 65 degrees. I'm going to use the same one from before, the 60 and 20 for the first fraction, and then the other one will be the new one in green. So we have wire 2 times sine of 60, 20 times sine of 65, divide out sine of 60. So 20 sine of 65 over sine of 60. Whoops, what am I doing? Is 20.93. But it says 2, does it say? Oh no, it doesn't say. Whatever, I'll just leave it in 10 still. So 20.9 for wire 2. Now, when you guys are doing this in Delta Math, when you guys are typing in your answer, you know how on Delta Math it always has like a little box, and then you type in your answer and press enter. But they also have little symbols where they have the minus and the plus. What you're going to do is select the little plus button, and that's going to open another text box so that you can put in 2 different answers, and it'll change it like this into curly brackets with a comma. And this is how you have to turn it in on Delta Math, because there are 2 different answers here. So just FYI for when you get to that problem. All right, and the very last question, we finally made it to the end. 3 friends are camping in the woods, Bert, Ernie, and Elmo. They each have their own tent, and their tents are set up in a triangle. So let me connect these these tents into a triangle shape. So, and then I'll just name them so that we know who's who. So I'll put Bert here, Ernie, and Elmo. So Bert and Ernie are 10 meters apart. The angle formed at Bert is 25 degrees. The angle formed at Elmo is 105 degrees. How far apart are Ernie and Elmo? So I do have a pair. I can see that right here in front, in the middle. And then the other pair that I'm trying to solve for. So I use sine of 105 over 10 is equal to sine of 25 over x. Cross multiply and divide, just like we've been doing the whole time. So 10 sine 25 over sine of 105, which is 4.38 approximately if you round up, 4.38. All right, and that's it. So this is the little trig review that I have created. I hope that this helps you for the SLO. And I'll see you guys later. Bye.